Okay, hello everyone. So I'm here actually not to tell you about another feature store implementation or even how we actually use feature store. I'd like to take this opportunity to introduce to you a tool that we're developing at DotData that can be used to kind of automatically generate features so you can feed your feature store. So I think we have heard people saying, like data is the new oil. If I write along this analogy, I think is to machine learning, development is actually the features that is the fuel here. And in that sense, I think, in my opinion, feature store is like the gas station. You drive up to it, plug in the pump, you get features flowing out of it to power your machine learning development and production. But where does this gas come from, right? I think it's just like, we have the oil industry to drill and extract, the crude oil and then turn them into the gas. We have this feature discovery process. And traditionally, this has been done mostly manually by data scientists. And we actually have a technology that can automatically do that. And I would like to show you that. Let me start with this example data set. So this is from a bank. This is an open data set. You may as well look at it already. With this data set, I'd like to build a machine learning model to predict if the loans are going to default. And I'd like to make this prediction at the time when the loans are applications are made. So of course, I have the loan data, the loan table, which contains this default status, which is the variable that I want to predict. I have the account information, the clients associated with these accounts, and some transactions data here as well. For a human data scientist, the task of preparing this data set to be used for machine learning can be a quite tedious one. You need to join all these tables together. You need to select the columns you want to use, find out, the right aggregate functions and the transformations and all that. With DotData, we can automatically do all that. So what is involved here is, there would be some basic cleansing. For the multi-table transformation, we have the auto joins and aggregations, which for temporal relationship among the different tables and columns. Of course, the usual, encoding stuff and some more sophisticated neural encoding and wavelet transformation on temporal data set. So in the end, right, starting from these multiple tables as the starting point, you get a flat feature table, and the features are selected solely based on statistical performance. So there is no kind of domain knowledge to actually also bias you here and limit the scope, because usually data scientists, given the input from domain expert, you can define features given what you already know, but there could be also features to be discovered well you don't know yet. Okay, with that, let me actually dive into my example implementation, which we have here on Databricks. We do support other platforms as well. We have this Python interface product. Essentially, it's the package where you can install, which you can install into your existing Python environment. For this example, however, we have the data stored in Delta Lake. We would load them as data frames and pass it to DotData. We would run a Spark job to discover the features, and then we can save those features into the Databricks feature store. Okay, so I would like to show some quick examples of the code snippets. I don't have a lot of time, but for the environment setup, I have this package imported as DDPy. So this is not pip installable yet. We don't have it open source, so you have to contact us if you want to experiment with it. So I'm loading all the tables I showed earlier here, all the 8 of them. With that, I also have a configuration builder object to help me put all this together. So I'm specifying here, the target table, and my target variable would be this default column. More importantly, I'm adding all the tables, each as a so-called data slot. So all the features will be explored from these as the source tables. And I also need to specify, how they connect to each other. So here, my target, the known, are connected on the known ID to the account table on the account ID. So these are all very straightforward. Maybe the only exception here is the connection between a target to the transactions table, because the transactions are temporal, by nature. So apart from matching on this account ID, I'm telling the job to look for entries, information for the past 6 months up to the point the application is made. And this is done by matching the two date columns from the two tables. So with this configuration, I can run my design features job. So it goes through a series of tasks. It would do the joins, extract the relevant records. Given the join conditions, we would explore the feature hypothesis for you and do the feature selection. So in the end, for this example, you can see that we have about 100,000 different feature hypotheses looked at. And then in the end, we selected 49 of them. And I have the list of feature definitions together with some statistics on the performance. So let me just take a close look at this first example. It reads, the count of records that satisfy, the balance below 4,192 within the past 6 months after the operation of a remittance to another bank. So this is basically looking at the two tables, the target containing the target variable and the transactions table. They are joined on this account ID, and with the date, falling into this past 6 months window. And we're essentially looking at the balance numbers after each occurrence of remittance to another bank, basically sending money to another bank account. And we're counting how many times that have happened that after this remittance to another bank, that the balance has fallen below this threshold. So I think this is kind of quite straightforward. This is found also statistically highly correlated to the target variable. Another one here, looking at the temporal change patterns, of this record count within the same time window. So all of our features are, defined in this manner, where you can, basically read them as plain English and try to find, the meaning of it. Okay, with all these feature definitions, I can then generate the feature values for any new data set. So here I'm loading another 8 tables. I map them, the data frames to the data slots that I have defined earlier. Then I can submit this generate features job to create the feature values for this new set of tables, and you can see the feature values here. So this is returned, as a data frame, so I can save them to my feature store. So here I'm using just the Databricks feature store, pushing this data frame to be saved. Okay, with all these features, feature values saved, then as a machine learning developer, I can then query the features I want from this feature store, and then build a model using my favorite machine learning library. So you can do that quite easily. Okay, so let me.
So do we have time to wrap up, Lou? We're kind of out of time, yeah?
Yeah. So let me just wrap this up with this slide. I think this is kind of the paradigm we see with this automated feature discovery component. You feed the data into the feature discovery. After some validation, you can then register the features in the catalogs, materialize them in the feature fit tables, and the features will be ready to be served for your machine learning building and scoring tasks. Okay, so I didn't have time to kind of show you more details, but if you're interested, please feel free to reach out to us. We would love to jump on a call and show you more of our tool. Thank you very much.